section is 3.7 optimization problem. So this problem is a word problem, okay? It's going to be all word problem, and they're going to ask you for either maximum or minimum. So you might have to read the question again and again several times. Alright, let's look at the first example. Find two positive number. So we have two positive number that the product is mean you multiply them is 185. So just from this first part, I'm going to set the equation x plus y, the product, so multiply, is 185. Alright, so that's from the first part. The product is 185, and then the sum is mean you add them is minimum. So I'm just gonna say S represent sum is x plus y. Alright, now we're gonna use you can use substitution method from algebra. So from here you can either solve for x or for y. I'm just gonna skip some algebra here. Alright, look at my note. I solve for y. Alright, so my y would be 185 over x. Now I'm gonna substitute my y in here to get my sum. So I will have sum is equal to x plus 185 over x. Alright, so I don't have to carry two variables, I eliminate one variable. And they ask for the minimum of sum, the minimum of the sum. So you have two options. You can do the first derivative test or the second derivative test. Alright, so what I did, I rewrite this. First step I do, I rewrite this as x plus 185 x to the minus 1. Right? Then take derivative of this. Take derivative of this with respect to x. So I'm gonna have the x is gonna be 1 minus 185 x to the negative 2. Alright, next step we're gonna set this equal to 0 and solve for a critical number. So 1 minus 185 x to the negative 2 equal to 0. I'm going to solve for x. I'm just going to skip algebra for now. Alright, so if I solve for x, my x is going to be square root of 185. And I'm going to use a second derivative test, not the first derivative test. So we're going to take derivative of this again to get my second derivative. So I take the second derivative test. I'm going to have 370 x to the negative 3. Alright? Or 370 over x to the cube. Because we run out of room, this, if you plug in square root of 185 in here, it's going to be positive. Alright, so it's going to be positive. Because this is your critical number. So it tells you that at this point is the minimum because it's positive. So minimum at x equal square root of 185. Again, if you substitute x in here and solve for y, you're going to have y is equal to square root of 185. Alright, I use the second derivative test. Suppose you want to do the first derivative test, you're going to put a critical number here, which is 185, and take the first derivative. Pick any number in this interval, plug it in the first derivative, you will get a negative here and a positive here, which means decreasing and then increasing, which implies a minimum. Let's look at the next example. The next example, a rancher has 400 feet of fencing in which to enclose 2 adjacent rectangular corrals. What dimension should be so that the enclosed area is maximum? So now again they ask for maximum. You can use first derivative test or second derivative test. But let's draw the picture. The shape of this is rectangular and they have 2 adjacent. Alright, so let's draw the picture. This is rectangular, right? 2 adjacent. So looks something like this. And we don't know the dimension of this. Let's call this x. The distance from here and here is x. The distance from here to here is also x. The vertical we call it y. So we have y all the way. Alright, so we want to fencing it. Fencing is you're going to have a distance from here to here, here to here, here to here, here to here, maybe in the middle as well. Alright, so how many x do I have? 1, 2, 3, 4. 4x, alright. How many y do I have? I have 1, 2, and 3. And it is 400 feet. Now I'm going to solve for one variable. Let's see, I'm going to solve for y. Right? So I'm going to solve for y. My y would be 400 minus 4x over 3. Skipped some algebra here. Now we want to find the maximum area. Maximum area. So the formula for the area will be length times width. Length times width. So I would have 2x. Alright, 2x plus times y. 2x times y. However, I don't want to have 2 variables. So instead of y here, I'm going to replace by this. Then I would have 2x, my y will be this, 400 minus 4x over 3, right? I did simplify this a little bit. So I distribute the x in and simplify this and factor. So I'm just going to skip step a little bit. So at the because we run out of room, so I'm going to have 8 over 3 100x minus x squared. Alright, this is just algebra if you solve and simplify it. So I have 8 over 3 times 100x minus x squared. Next step, you can use the first derivative test or second derivative test. I like to do second derivative test. Right? So the first derivative, we're going to take derivative of the a over the x. So 8 over 3 is just constant. So it's 8 over 3. Derivatives of 100x is 100. Derivative of minus x squared is 2x. Alright. Next step, I need to get the critical number. So I will set this equal to 0. Set this equal to 0. And then solve for x. if I solve for x, which I'm skip step here, my x is going to be 50. This is my critical number. Okay. Next step I'm going to do, I'm going to take second derivative of the function. So I'm going to have negative 16 over 3, which is going to be always less than 0 because we don't have variable here. So this is relative max. So substitute the x in here, you're going to get the y. Alright, so A is at maximum when x equal to 50. Again, I substitute x in here. I got y equal to 66.67. Okay, let's go to the next example. Hi everyone, let's go to our next example. From this example, you can use either the first derivative test or the second derivative test. I would personally do second derivative test because it's much faster. However, you're welcome to do the first derivative test. Sometimes if it's too difficult to take second derivative, you might want to do the first derivative. So make sure you know both. Also, because of limited of space, I will skip some basic algebra. So make sure when you watch this video, maybe watch it more than one time and try to redo it yourself just to make sure that you really understand everything. Alright, so let's look at our third example. Determine the dimension of a rectangle solid with a square base with the maximum volume if its surface area is 337.5 square centimeter. A lot of time, I'm not going to give you a picture, but because it takes me time to draw the picture and I don't know how to draw, so anyway. So it's a three-dimensional and they want you to find the maximum volume and they give you the surface. Alright, so they give you the surface, they want you to find the maximum volume. And they tell you that it's the rectangular solid with square base. So this is the picture. You're going to have a square base. So let's call it x and x. Alright, the height, I call it y. Okay, let's look at the equation. So they tell you the surface is 337.5. We know we have the top, and think of it as a two top, up here and down here. Alright, so I'm going to plug in the number. The surface is 337.5. Two top. So my top, I have x times x is x squared, but I have one of them here, one of them up there. So I'm going to have 2x squared. Alright, and the side, I have the side here, and one on the back. So the side will be x times y, but I have 4 of them. So plus 4xy. Now I have two variables, x and y. I'm going to skip step again. I'm just going to solve for y. Right? So my y is going to be 337.5 minus 2x squared over 4x. Let's box it so we come back to it later. Alright, you might want to check my algebra here. It's correct, but just so that you know what to do. Now they want you to find the maximum volume. The volume of this is going to be area of the base times height. Alright, the volume is area of the base times height. Alright, the base is just a square base. So x times x, right? X times x. The height is my y. That's the height. want to have two variables, I want to substitute y with this whole thing here. Alright? So I'm going to have x squared, and instead of my y, I will have this. 337.5 minus 2x squared over 4x. That's my y. Now I'm going to distribute the x in and simplify a little bit. Then I would have 84.375x minus 1/2 x to the cube. Again, I skipped some algebra here just to because we have limited of space. So this is your volume. Now I need to have a maximum volume. Again, I'm going to use a second derivative test. I'm going to take derivative of this by critical number, right? So dv dx, derivative of this is just going to be 84.375. Bring the 3 up. So it's going to be minus 3 over 2x squared. That's my first derivative test. You would set it equal to 0 and solve for x. That's your critical number. So I'm going to skip step here. So if you solve for x, you should get x equal to 7.5. Alright, this is your critical number. Now I'm going to use second derivative test. Take derivative again of this. I have, negative 3x. Alright, if I substitute critical number, which is 7.5, obviously is less than 0, so that is relative mass. So is the maximum volume when x is equal to 7.5, and you plug 7.5 in here to solve for y. So maximum volume would be x equal to 7.5 and y is also 7.5. Once you substitute x in here, you should get the y. So that's example 3. Let's look at the next example. Right. A rectangle is bound by the x and y axis. So this is my y and this is my x. And the graph of y equal to parenthesis x minus 6 cos parenthesis divided by 2. This graph is linear. If you look at it, it's a linear, it's a line. Alright, we go to that later. What length and width? I think I misspelled it. Not width. Should the rectangle have so that its area is maximum? Alright, so let's graph this. This is linear, alright? If I substitute 0 for x, I'm going to have 6 divided by 2, which is 3. So when x is 0, y is 3. Let's make it easy to myself. Let x be 6. X be 6, y would be 0. Alright? Again, we have a linear, so 2 points is enough. So that's going to be my line. So the rectangle bound by the y-axis, the x-axis, and this line. So it's not going to go over there. Alright? So, and they want you to find the length and the width that give them the maximum area. So I don't know where it is. Let's say somewhere here, I just make it. So your rectangle should be somewhere here. inside, not out there. Alright, so let's area, start from area because they want the maximum area. Area is length times width. Alright, I'm gonna get rid of one variable, so substitute y with this. So I'm gonna have x 6 minus x divided by 2. Alright, divide by 2 just for the second term. Yeah, make it clear. Alright, next step, what did I do? I take the 1/2, I distribute the x in and take out the 1/2, so I have 1/2 6x minus x squared. So this 1/2 is just this 1/2. I distribute the 6 in. Alright. Next step, I'm gonna use find critical number. Take the first derivative of this. So my 1/2 is just 1/2. Derivative of this would be 6. Derivative of this will be minus 2x. Let's make it easy for myself. Yes. Next step, I would set it equal to 0 and solve for critical number. Is set it equal to 0, so x would be 3. That's your critical number. Okay. Again, I'm using second derivative test because it's not too difficult to take second derivative of this. So take the second derivative of a function. So I have -1 because this is 0, -2 divide by 1/2, -1. So this one is less than 0 no matter what. Okay. So relative max at x equal to 3. We can substitute 3 in a function. I substitute 3 in a function right here. Okay, so maximum area when x equal to 3 and y would be 3/2 once you substitute it in. Y would be 3/2. Substitute for y. Alright, I just finished 3.7. See you later.